So the reason, one of the reasons as engineers we're interested in sustainability is because the things that we build are big. They use a lot of energy. They use a lot of materials. And as some of the talks this morning pointed out, that's having big impacts on the natural environment and human health. And there have been different attempts to try to quantify how much specifically buildings, their impact is on the environment. So this is just one study from the Royal Architectural Institute of Canada. And they claim that buildings account for nearly half of all greenhouse gas emissions in Canada. As you start to look through various different papers, you're going to find some slightly different numbers quoted, but suffice to say, it's a large number. So more and more engineers are being asked how green and sustainable are the things that we build, and are there things that we can do to make it more sustainable. So one of the kinds of measures that's being looked at and people are trying to quantify is something called embodied energy. So this morning, a lot of information about energy and different sources of energy and the impact those different sources of energy have on the environment. So the idea of embodied energy is just simply trying to quantify how much energy is needed to produce a certain amount of a material. So whether it's a kilogram or a meter cubed. And that means all the energy to extract, to refine it, process it, transport it, fabricate it. So there have been all sorts of different attempts to do this, but this is one that I like. It comes from some work at the University of Bath, and it's called the Inventory of Carbon and Energy. And I like it because it's a nice simple format, basically a spreadsheet format. And they list various different types of building materials. And basically the values of embodied energy for these different materials. So this column here, EE, just standing for embodied energy, and the units on that they're using are megajoules per kilogram. So the megajoules of energy needed to produce a kilogram of that particular material. So I don't know what a megajoule is. To sort of help me try to understand it, if you burn a liter of gasoline, that's about 42 megajoules of energy. If you want a more sustainable measure, if you bike for 25 kilometers an hour, for 1 hour, you're going to burn about 2.9 megajoules of energy. 150 pounds. No, it is specific for your, yeah. Anyway, so here are a few common construction materials that many of us are familiar with. Cement. We know that we often offset cement using other materials, but this is just plain Portland cement. It requires about 5.5 megajoules per kilogram. Steel. So if you actually take the iron ore out of the ground, process it to create structural steel, 35.4, massive amount of energy. Much of the steel that we're using is actually recycled, so that uses a much more modest amount of energy, 9.4 megajoules. If we look at timber, it falls somewhere in between cement and steel at about 7.4 megajoules per kilogram. This is just basically plain sawn softwood. As you get more engineered timber products, the amount of embodied energy goes up. And to just kind of give sort of another comparison, this is a non-structural material, but one that's used a lot in buildings. Fiberglass insulation uses up to 28 megajoules of energy in a kilogram of its production. So there are a couple things, first of all, to just keep in mind. One is that the numbers don't really mean anything until you look at the entire building that you've designed. So if you use a whole lot of concrete and massive amounts of cement, then the total amount of energy embodied in that building and the materials is obviously much higher. Fiberglass doesn't weigh a whole lot, so yes, in a kilogram of that material, there's a lot of energy, but you may not need many, many kilograms of that material to insulate your building.
This is very interesting and rather surprising, at least to me, numbers, especially for cement. I would have thought it's higher than that. But would you by any chance have which is a different quantity, the CO2 emissions?
They do have those, yeah. So if you look in the in the spreadsheet they have, so this EC is embodied carbon. EC, so kilograms of carbon dioxide essentially that would result from the production of a kilogram.
I suppose cement will not be a winner in this case.
Yeah, so definitely cement for the embodied carbon falls down. So I didn't want to have too many different numbers, but yeah. But yes, yeah, certainly those are those numbers are available as well. But I should, yeah. So this these numbers are based on production of those materials in the UK, and so there's certainly other people who produce numbers for Canada. Some of them are a little bit harder to sort of track down. They're not in quite as straightforward a setup as the spreadsheet that I showed you. But one thing just beware is that those numbers will vary country to country. So depending on how materials are produced and the energy that's being used and transportation, those numbers will vary. So location to location. In any event, knowing and understanding the how much energy goes into our materials and the fact that the production of carbon from producing those materials can be having big impacts on the environment has sort of led an interest into low carbon building materials. So I just want to talk about two that I'm familiar with. And the first one is straw bale building panels, and the second is cement stabilized earth construction. So straw bale building panel, exactly as the name suggests, you're essentially replacing fiberglass insulation or another form of insulation with just common bales of straw. In this case, the way they're doing this is they're packing those bales of straw into a timber frame, and then a plaster is applied to each side of that of the straw to give it strength and also to protect the straw. So you can build houses out of straw. So this was one that was built a few years back in Peterborough, Ontario. So that's about 2 hours west of Kingston. This is built just in a regular subdivision in Peterborough. And you can see these panels are actually built off site and then transported to the site and assembled. This is actually a bigger building in England, in Bristol. This is a 2-story building. The main frame, structural frame, is actually concrete. And in this case, the straw bale panels were used essentially as cladding to infill the concrete frame. Another concept has been to use earth, which is probably one of the oldest building materials. So what's done, this on the right hand is, this was actually a house being built exactly a year ago, so September 2014. It's almost done now. But the way they're building these walls is to take essentially sort of an engineered mixture of soil, so clay and sand, and about 5% cement is added to that mix. What they do is they have formwork, and the mixture is packed into the formwork and then densified. So you can sort of see the layers where they've built up the wall using this mixture. There's some insulation in between the two layers of that soil. So in that way you can build up your walls. Here's an actual completed, it's not this one, but another house here in Ontario that was completed a few years ago. So there's definitely an interest in trying to come up with designs, materials that will reduce the impact that's created on the environment. There are lots of good materials and information out there. if you're interested in applying principles of sustainability to building design. So I won't go through all these. This is a good one from the Royal Academy of Engineering because it's short. It just gets to the point. It has kind of a number of principles to follow, and it gives some good case studies. And I just want to show one picture from that to kind of sort of point out some of the things to be watching out for. So they really kind of emphasize that if you want to come up with a really sustainable design, like to truly meet something that's actually sustainable, it's not simply, you know, improving how well you're using materials or, you know, reducing, you know, energy use by X%. All of that's important, but it's only a small part of it. As they point out, there are really kind of three big things that you should be looking at. There's sort of the technical things, which as engineers we can look at, and those are things like, hey, we're going to improve the design by X% or whatever. There are environmental concerns about natural resources and how we're using them, but there are also some really important social concerns as well. Everything from, you know, how this thing that we're building or what we're designing, how that's going to impact the people in the neighborhood, in that area, and future generations as well. So it's really sort of three different important things. As engineers, we're kind of focused on this, but it's important we kind of keep in mind some of these other things as well. It's only until you kind of have those three things coming together that it's actually a truly sustainable design.